Hi guys, this is Mr. Lees here doing the SQA Higher Mathematics paper from 2019, paper 2, and we're on question 7, where for 7a you have to express minus 6x squared plus 24x, take away 25 in the form p times x plus q squared plus r. So let's get on with that one there before we do part b. So there we have it there. So there's our task, set that in that form there. So the first thing we do is we expand this side, so x plus q squared means x plus q times x plus q. Multiply that out, you get x squared plus 2qx plus q squared. We then multiply that by p, and we get px squared plus 2pqx plus pq squared plus r. So that is that all expanded out. This allows us to compare coefficients. That means that p has to be minus 6 and 2pq has to be 24. So 2pq being 24, we know that p is minus 6. 2 times minus 6 is minus 12. 24 divided by minus 12 gives q to be minus 2. We then have pq squared plus r being minus 25. That's that there, equaling that there. We know what p is, we know what q is now, so we can multiply this out and we get minus 24 plus r is minus 25, so r has to be minus 1. So we now know what p, q and r are, so we can write that minus 6x squared plus 24x take 25 is minus 6 times x take 2 squared, take away 1. And then for part b, we are, just to go back to the question, we are given that f of x is minus 2x cubed plus 12x squared, take 25x plus 9. Show that this function is strictly decreasing. That means we have to show that the gradient is always negative for all values of r. So let's go back to the working, and here we have it there. I'll just center it for you a little bit better. There we go. So there's f of x, and we're now going to differentiate it to get a formula for the gradient. So minus 2 times 3 is minus 6x squared, 2 12s 24, x to the power of 1, take away 25. Of course, hopefully you were all waiting for this. That's what we were dealing with in part A. So f dash x is that there, which of course we immediately swap for the answer that we got for part A. So this is a formula for f dash x. Why is that always negative for every value of x? Well, let's deal with x take 2 squared. If you square something, you always get an answer greater than or equal to 0. If you then multiply that by negative 6, you will always get an answer less than or equal to 0. And then, if you take away 1, you will always get an answer less than or equal to minus 1. So the gradient is always less than or equal to minus 1, f dash x. So just recapping that, the gradient is always less than or equal to minus 1. So the function is always decreasing for all values of x in real numbers. And that is your answer there.